Scott Fybush here at the NAB booth talking with the one and only Minister of Algorithms, Mr. Steve Dove himself, who we have just learned should be addressed as your decibel.
Indeed.
And we are talking...
You are anointed.
We are talking about distortion, and you gave a talk here at NAB about why sometimes 0.01 dB matters, or 0.01% matters.
That's right.
And why sometimes 30% distortion may not matter.
And sometimes at the same time.
At the same time.
Curious, because here we are in the 21st century, and we've been able to make essentially 0% distortion product for the last 40 years at least. So why are we still arguing or talking about distortion? And that's because there's a lot of it about, either by accident or, in our case, sometimes by design. Heaven, why would we deliberately build distortion into things? Well, we make air chain processors, and the way you make things sound loud is by deliberately distorting them, but you hide the distortion products. You find these distortion products, and then you've got to find somewhere to tuck them away and hide them. And the most useful technique for this is critical band masking, which is a feature of the human ear whereby if you have a solid signal, immediately either side of it, like a tent, is a region where whatever product is there is inaudible because the ear is busy concentrating on the main signal.
So this is the same sort of perceptual coding that you would use, say, for a ppm watermark?
Yes, indeed. It's exactly the same thing. And of course, it's the same general technology as has allowed MP3. Mm-hmm. That's one aspect of distortion. Yes, you can generate distortion, and because of the way the ear works, you don't hear it, but you can add psychoacoustic effects which make things sound richer and louder and so on and so forth. For instance, at the low frequency end, we deliberately add some products which are higher in frequency than the bass. And why would we deliberately do that? It's not just purely to build loudness. It's because most of the audience, 80% of the audience, is listening on silly little white things you stuff in your ear, or tiny little speakers in cars or transistor radios and so on and so forth, which don't respond to bass at all. So you have to create some energy which sounds like bass for 80% of your audience. If the other 20% are listening in BMWs or have huge hi-fis at home and go, yeah, the bass, then okay, that's a bonus, but that's not why we do it.
You must be driving in better BMWs than I ever get to ride.
And when does the 0.01% matter? The funny thing is, it's a lovely paradox. I really enjoy this, in that I just used the example of bass as how you can get away with murder in the distortion stakes and get away with it. The paradox is that you use bass, or this is a really good example, using bass as how you can hear a 0.01% product. And it's all to do with the Fletcher-Munson curve. Ancient researchers who basically defined the frequency response of the human ear. And because of the way the human ear is constructed, in particular the eardrum, the suspension of the eardrum is a high-pass filter which starts at about 700, 800 hertz and dives on down, which means that the ear is very insensitive to bass. In fact, let's say 100 hertz. Let's have our 100 hertz signal, and it's got a distortion product 80 dB down, 0.01% distortion. Was there 0.01% distortion? But the trouble is, because of the way the frequency response of the human ear, it isn't 80 dB down, because the 100 hertz is being attenuated by about 50 dB in relation to the mid-band, 2 kilohertz, 3 kilohertz. So now you're down to a mere 30 dB down. Trust me, you hear that. It's like sore thumb. So there's the wonderful paradox of using bass as an example where 50% distortion doesn't matter, but under other circumstances, 0.01, you hear it.
Matters immensely.